All right, everyone. During our time together today, we're going to review solving systems of equations by graphing. You have a worksheet that should be handed out to you. On this worksheet, you'll have 12 problems, but we're going to go through 3 of them together. So make sure you stay on point so you have these ones jotted down. Reminders while I'm away, please sit in your assigned seats. Please be respectful. I love it when subs brag about my students, so let's make that happen. You may not leave the room to work today unless Mrs. Rutten or Mr. Nanda has pulled you aside to work with you. Pay attention to the video. We're going to work out those problems together. And then our unit test will be when I return. So don't just rely on class time to prepare for the test. You do have to study on your own. You'll have everything you need to study from. On your worksheet, let's take a look at number 1. Remember your steps for solving by graphing. First, we need to take each equation and we need to solve for y. I'm going to start off by subtracting x from both sides, which leaves me with a negative 2y equals a negative x plus 2. I then need to divide every single term by negative 2. Be careful, technically there's a 1 in front of this x. Does 1 over 2 reduce? It doesn't, so I'm stuck with 1/2, but a negative over a negative does become a positive. Then I have a positive 2 divided by a negative 2, which leaves me with a negative 1. Let's graph this line first. I start at my y-intercept of negative 1. I then count my slope. I'm going to rise 1, run 2. Rise 1, run 2. Make sure you fill in your whole graph. This is an equals to. It's an equation, so it's going to be a solid line. Don't forget your arrows on the ends. All right, let's take a look at the second equation. My first goal is to get y by itself. I'm going to subtract x from both sides. That leaves me with 4y equals negative x minus 16. Divide every single term by 4. That leaves me with y equals. This is technically a negative 1 over 4. 1 over 4 does not reduce, it stays 1/4. 16 over 4 does reduce to negative 4. All right, let's plot this line. Start at your y-intercept of negative 4. Count out your slope. Rise negative 1, run 4. Rise negative 1, run 4. Go the other direction. Rise 1, run negative 4. Notice our points collide here, so make that point really big. Let's keep going. 1, 4. It's or equals to, so it's going to be a solid line. And what we want to do is take that intersection point, and that becomes our final solution. So we went left 1, 2, 3, 4, so negative 4. We went down 1, 2, 3, so negative 3. That is the solution to our graph. Let's take a look at number 2. First of all, I want to take that first equation and I want to get y by itself. So we're going to take that 4x and subtract it to the other side. We're going to write it as negative 4x plus 9 because we want it in that slope-intercept form. Divide every single term by 3, which leaves me with y equals 4 over 3 does not reduce, but 9 over 3 does divide into 3. Let's plot this line. My y-intercept is 3. I'm going to count my slope out just as it says. Rise -4, run +3. Down 4, right 3, down 4, right 3. Go the other direction. Up 4, left 3. And I can't go up 4, so that's my full line. Connect your dots with a nice straight line, arrows on the ends. Our second line is just x equals 3. There's nothing to solve here. So we read it very literal, remember? Go to the x-axis at 3 and put a dot. Now, does it make sense for our line to be horizontal or vertical? Well, if it's horizontal, that'd be the axis. I'd be drawing along the x-axis. That doesn't make sense. So we need to draw a vertical line through 3 on the x-axis. And you'll notice when we do that, we hit one of our points from our other line. Therefore, that intersection point becomes our solution. To get to that overlapping point, we go right 3, down 1. Our coordinate value is 3, -1. Okay, let's take a look at number 3. First step, I want to get y by itself. The first equation, y is by itself, and it's already in slope-intercept form. So let's jump straight into graphing. We're going to go up to 5 on our y-intercept. 1, 2, 3, 4, 5. We want to count our slope. Now technically this is a -2/1. So as I count, rise or go down -2, right 1. Down -2, right 1. Keep going, down -2, right 1. We want to fill up that whole graph. Go the other direction as well. Okay, now we want to fill in that line. Oops. And hopefully your line's a lot straighter than mine. Okay, let's take a look at the second linear equation. I do have to do some algebraic work here. What should we do first? All right, hopefully someone said subtract 4x, which leaves me with 2y equals -4x minus 12. How do we get y by itself? Divide every single term by 2. When we do that, we end up at y equals 4 is divisible by 2, and 12 is divisible by 2. Let's start with our y-intercept at -6. 1, 2, 3, 4, 5, 6. Our slope is -2. Wait a second, what do you notice? Take a look at our slopes of both lines. If our slopes are the same, what kind of lines are we going to end up with? Parallel lines. So still graph this line as you would any other line, using that slope of -2. Still connect your dots, still draw arrows on the ends. But what we've already determined is these are parallel. So when do they intersect? Never. So this is an example where we would write no solution. No solution. They never cross each other's paths, so they never have an intersecting point. All right, your goal for the rest of this class is to work on the rest of the worksheet. I look forward to getting an excellent behavior report. And know that our sub does have the key. So if you want to check an answer of what the intersection point is, please ask her. I still have to see all of your correct work, of course. So make sure you check those answers as you work. Know that as far as completion, if everyone works fully and I get a good report back, these won't count against you if you don't finish them. If I see that you only did the examples in class and you didn't work on any others, then they'll be due. So just work well, study well, and we'll see you soon.